So first, we gathered temperature, humidity, rain, and even wind speed data for every single day over a 6.5-year period. This was done for multiple cities in the United States. The data was merged with a dataset containing wildfire dates obtained from the USDA Forest Service. Of course, the wildfire dataset had been filtered for all anomalous results such as those caused by arson or even nearby railroads.
We applied principal component analysis to reduce the dimensionality of our dataset. This made it easier to visualize relationships between different factors in wildfire occurrence. Using this information, we trained and tested a support vector machine-based model on California weather data. We found that the model had 74.8% accuracy.
We used the OpenStreetMap API to obtain coordinates for all the forests in both California and Nevada. We used the Dark Sky API to obtain real-time weather data for each of these locations. We could only get one day of past weather data, so we created an automatically updating database. This allows us to have the past 14 days of weather data for each location. We merged this with the future 1-week weather forecast before feeding it into our model.
Real-time data was fed into the model produced by the support vector machine. Traditionally, support vector machines aren't capable of determining the probability that a value lies in a class. We needed such values as our output. Plat scaling was employed to solve this problem. Plat scaling aims to create probability estimates over classes by applying a logistic transformation to data points.
And this is what it looks like once we can visualize the results on WebWorldWind. As you can see, the likelihood of a fire for each of these locations are shown. If the circle is red, then there is quite a high chance of a wildfire occurring. We have already predicted multiple wildfires in the 3 days the app has been live. You can search through the likelihood on different days and it will give you the updated results quickly and smoothly. The website was created in a Django framework to make passing data into WebWorldWind easier. We use Ginger templating to pass output data from the SVM into the JavaScript that controls our WebWorldWind application. All the files for Django, the website, and of course our SVM are hosted together on a web server. Due to the real-time nature of our app, we needed a server so we could have our scripts constantly running.
WebWorldWind features we implemented on the site include annotations when you highlight a certain placemark, a search bar, and a filter that allows you to filter wildfire locations based on their probabilities.